Often when we're finding the area or volume of something, we don't have the exact shape that we have a formula for. And so we have to break it up into some known shapes. That way we can actually find the area or volume of whatever shape we're interested in. For example, let's say I've got this funny shape here that starts with kind of that right angle, and then I'm going to put a half circle on the end of that, and I'm going to come up to a point and come down. This shape is really unique. And I'm going to say I know the entire distance to the top is 6. I know the distance on the left side is 4, and this bottom distance is 9. We should be able to figure out the area of the shape even though we don't have a formula for it. The way we do it is we have to break it up into known shapes. One thing I see is we've got a half circle on the edge here. And that half circle, that height, if I look over to the left side, is the same as the height of the left side. So the total height of the circle is 4. That's the diameter. And with circles, we're particularly interested in the radius, which is half the diameter, or 2. Another thing you might notice is if I were to draw a horizontal line through the shape, we end up with a triangle on top. Well, if the whole distance to the top is 6, and the bottom part is 4, that top part is going to have a height of only 2, and the base is 9. So we've actually got 3 shapes going on. First, a rectangle. I see this green rectangle is 9 by 4. So area of a rectangle is base times height, 9 times 4, which is 36. I also see this triangle on the top. The area of a triangle is 1/2 times the base, which is 9, times the height that we figured out was 2. That's going to give us a total area of 9. And then finally, on the left, there's this little half circle. The half circle has a radius of 2, we said. So area of a circle is pi times the radius of 2 squared. But we don't have the whole circle. We only have half the circle. So I'm also going to divide that answer by 2. When I do that, I end up with 2 times pi. And 2 times 3.14 is about 6.28. So to get my total area of the shape, we have to add these 3 shapes together. And when I add 9 plus 36 plus 6.28, I'm going to get a total area of 51.28 square units. Let's do another shape. Let's say if we take a circle, and then I'm going to put another circle inside it and another circle inside it so that those 2 circles are touching. It kind of looks like eyes on a face. We're going to find the area of this shaded stuff, the big circle with the 2 little circles cut out of it. And I'm going to tell you that the distance across one of those little circles is 2. Let's think about this big circle for a minute. This big circle, from the center to the edge, we know is 2. That means we can find the area is pi times the radius of 2 squared, pi r squared. Well, 2 squared is 4 times pi, and 4 times pi is about 12.56. But then we've got these smaller circles. If the whole distance across is 2, half the distance, the radius, which we care about, is 1. So that's going to give us pi times 1 squared, which is equal to 1 pi, or 1 times 3.14, which is 3.14. But remember, there's 2 of them, one on the left and one on the right. And so if I want the total area, the 12.56 is shaded, but then we subtract the 3.14, that white spot that's cut out, subtract the other 3.14 that's cut out, and that's going to give me a total of 6.28 square units that are shaded with that white part cut out. So as we break it into known shapes, sometimes we have to add the shapes together, sometimes we have to cut them out or subtract them out, and that can give us the total area of these unknown, unusual composition shapes.